Hi. Today what we'll do is today we'll learn how this power sequence flow in any motherboards. So these are the ladders where all the signals flow. So first when you connect the adapter to the any laptop, first the power comes and that power is called the always voltage. It's called the always voltage. It goes to the SIO and the PCH. That voltage is supposed to be 3 volt. And before power on you should get a 3.3 and 5 volt at the always section. Okay, so this is the first steps. So before turning on the laptop, turning on the switch, you should get a 3 volt on any laptop, and this voltage is called the always voltage. And when you turn on the switch, then the all voltage comes out. The voltage 1.5, 1.35, 1.05, 3.35 graphics and CPU core, and it goes to the particular switch to the entire motherboard. So these are the power. This voltage comes before power on, it's called the always voltage, and this voltage comes after the power on. Once the motherboard gets the power, the next signal is generated, that is a power good. The power good signal, it's called the confirmation signal that all power planes are steady now and they are ready to work, and that signal is called the power good. After that, the motherboard get reset. In motherboard is a combination of lakhs of MOSFETs. So the reset signal, what he do, he's a clear all the junk information on the motherboard. He clear the RAM, clear the CPU, clear everything on the motherboard and keep ready for work. And that signal is called the reset signal. There are 2-3 reset. One is called the PLT reset, it's called the platform reset. Another is called the CPU reset. Then the PCI reset. After the reset, motherboard is ready to work and motherboard get the clock. The clock, it's called the frequency, the different frequencies the motherboard have, the CPU, then PCH, then BIOS, and then SIO, then RAM. All these different chips require different frequencies. Okay, so the clock department, what he do, he provide a different frequencies to the entire motherboard. So that job is a clock department. After that, BIOS start reading, CPU access the BIOS and read the BIOS. So BIOS do the startup work. He just do a startup, just like he do the self, and he do a post. It's called the power on self test. He tests the all devices are there or not. He tests whether they are working or not. They initialize them and they are ready to work. That is the job of post power on self test. And the last, after the post completed, if it is any error, then BIOS generate a code that is called the error code that we can see on the debug card. And if we pass that this power on self test post code, then the display will be appear. And in this way, this flow is go like this in this any motherboards. Yeah. In the next is in the entire motherboard there are multiple pulse width modulator. These are the different pulse width modulator, right? So here are 2 pulse width modulator for 3.3 voltage, 5 voltage, and here is a pulse width modulator for 1.5 voltage, 1.8 volt, 1.05 volt. This is for the graphics chips, graphics core volt, and this one is called the CPU core. CPU core require a higher current, is require more than 20 ampere. So here are the 2 pulse width modulator provided to the CPU. And the next is, this is called for the battery charging purpose. So here are, you can see there are different pulse width modulator for the different sections on the motherboard. So in this next screen we can see this different pulse width modulator goes to the different power, like this is the always voltage is generated 5 volt and 3 volt. This 3 volt goes to the SIO, this always voltage, and here is a MOSFET. This side voltage is called the always voltage and this side voltage is called the suspend voltage. Why it's called the suspend voltage? Because this voltage turn on or goes out when you press the power button. Okay, so that's why it's called the suspend voltage. This suspend 3.3 goes to the BIOS, then the PCH, then the RAM, and this 1.5 voltage, this is also generate after turn on the power button. This 1.5 volt goes to the PCH, then this 1.3 volt goes to the DDR3L RAM, and the processor 1.05, that is this is system voltage, is goes to the PCH, and it goes to the CPU. And finally this is called the CPU core section. There are two voltages, one is called a CPU core voltage and another is called the graphics core voltage. There are the two voltages goes to the CPU. So this different pulse width modulator generate a different voltages, and it goes to the particular chips on the motherboard. So have you seen how this section is work? In next diagram we'll see how this next section work. These are the main manufacturer of the motherboard. There are four main manufacturer on the motherboard in the world. This is called the Compal motherboard. The Compal motherboard numbers start from LA something something something. It's called the Compal motherboard. Then this Quanta motherboard. The Quanta motherboard numbers start from this DA0 or something R is indicating, and something something number, that is called the Quanta motherboard. The next is called the Wistron motherboard. Wistron motherboard number 5-digit number, and then -1 or -2 or -3 like that. And this next is called the Inventec motherboard. So long numbers. So these are the main four manufacturers of the motherboard. Okay. So when we open any laptop, you can see this number located on the motherboard, any of this corner. So you have to locate the number, and from that location you get the diagrams. You can download the motherboard from any of the site or the pay site or free site, whichever is convenient to you. You can download the schematic diagram. These are the four main manufacturers of the motherboard. So next is now what we'll do is we'll see this Compal motherboard. This is a Compal motherboard, a flow chart, and in this motherboard we'll see the how power plane flow, how this voltage flow, how the signals are flow, and how can we repair a dead motherboard in this any Compal laptop motherboard. Okay. So first I'll introduce the component. This is the processor, CPU, then this one is a PCH, then this one is SIO, this is a BIOS, and these are the two inputs. One is an adapter, another is a battery. This voltage section, this adapter and battery charging section is called the voltage section, is here. Any one voltage goes inside. If we connect the both voltage, if it is adapter and battery also there, then only one voltage pass. Okay. And these are the different pulse width modulator. This always voltage is that there are two pulse width modulator, one for this 3 volt and another is for the 5 volt. There are two pulse width modulator, and this voltage is generated before power on. The next is this is for 1.5 voltage, basically for the RAM. If it is a RAM DDR3L, then here voltage will be 1.35. If it is a RAM DDR3, then here voltage will be 1.5 volt. Then next is 1.8 volt, 1.05. This is the system voltage. And finally this is called the CPU core voltage. In CPU core there are two sections. One is for the graphics core and another is a CPU core. So these are the different pulse width modulator, and here are two MOSFET. This side voltage is called the always voltage, and this side is voltage called the suspend voltage. Now if I connect the adapter, my 18 volt goes inside and it goes to the different pulse width modulator. You can see in this animation my 18 volt pass to the different pulse width modulator. It goes to the all the input sections. Then this section won't work unless they won't get a enable signal. They won't work. This particular section will work, and he will generate this 3.3 and 5 volt. You can see in this animation this 3 volt and 5 volt is generated, and this 3 volt goes to the SIO, and this 3 volt goes to the EC bias if it is there, otherwise only SIO. And this both the voltage are stopped here by two MOSFETs, because this side is voltage called the always voltage. This voltage turn on before power on switch, and here is also 3 voltages stop. So now the next is called my power button. Then my third step is power button. that is called a EC power button, power on, or NBS power on, something like that, or there are maybe 2-3 names given for the power switch. Either are NBS W on, power on, or on off switch. Okay, so here you can find 3 volt and the another leg is connected to the ground. Okay, now this is when I press the switch like this, you can see in this animation, when I press the switch, my 3 volt goes to 0, and if I release that button, my 3 volt goes to again 3. So 303 pulse will be generated at this power on button. Once SIO get this pulse, what SIO will do, he generate the next signal that is called the PCH power enable. He generate the PCH power enable and trigger this MOSFET. He trigger this MOSFET. After triggering this MOSFET, my voltage will pass this MOSFET and goes to the PCH, and PCH got the power. And this voltage I can check. If it is HM55 PCH, then this voltage I can check on this capacitor. Okay, so after the 10 millisecond delay, my next signal will be generated, that is called the resume and reset. Here before power on switch, here I get a 0 volt. After power on switch, I should get a 3 volt, that is called the RSM RST. If my my entire section is working, then here I should get a 3 volt. And if I get a 0 volt after pressing this button, that means probably my fault could be either SIO or my EC bias, something related to this. So I should get a 3 volt here. Okay, once SIO generate RSM RST to the PCH get reset, his power plane is ready to work, power management ready to work, and within a next microsecond SIO generate the another signal that is called the PM power button, or it's called the DNB power button, or it's called the PM power button. This is called the post power button, or it's called the digital power button, that saying SIO to the PCH ki power on button is pressed, you ready for work, or give me the permission to turn on the laptop. He is asking to PCH. So here firstly here is the 3 volt, then it goes 0 and again back to the 3. So 303 pulse generated at this pin, that is called the PM power button. The next is when the PCH got the signal PM power button, now the PCH has to reply to the SIO. He has to give the answer to the SIO. So PCH, what if everything is okay, if everything is ready and power management is ready to work, what the PCH do, he send the 2 signal, and that is called slip mode 3 and slip mode 4. He send the 2 signal SLP S3 and SLP S4 like this. He sent the 2 signal. Here previously it was a 0 volt before power on, and now it's become a 3 volt here. I should get here 3 volt on. We can check all these voltages on SI only, because we can't check the PCH directly. So we can check all this voltage on SIO pen. Okay, so I should get here a 3 volt. If a 3 volt is not come here after PCH getting this signal, that means probably my fault could be PCH could be bad. So I have to check like that. So if it is a 3 volts comes here properly, that means PCH given permission to the SIO to turn on the laptop. The next signal is when SIO got this confirmation from the PCH, he generate the next signal that is called a system power on or sys on. The sys on signal generate and give the enable signal to this pulse width modulator, and then this 1.5 volt will be generated, and this 1.5 volt goes to the RAM, PCH and the CPU, all 3 chips. This 1.5 goes to the CPU, PCH as well as the RAM. The next signal is within a few microseconds, SIO generate the next signal that is called a SUSP, that is called the suspend on. He generate the next signal on the 10th section. He generate the next signal that is called the SUSP. When the SPUSP signal is generated, he trigger these 4 sections. Firstly, he trigger this MOSFET, he trigger this MOSFET gate and pass this voltage to this side, that side, another side, and this 3 volt become a 3 volt suspend and it goes to the entire motherboard. This 5 volt become the 5 volt suspend and it goes to the entire motherboard, like a hard disk, DVD writer, fan, everywhere it goes to the outside. Okay, the next is he trigger this 2 section, that is called a 1.8 volt. He turn on this 1.8 volt, that is called a system voltage, and then the next is called the 1.05 voltage. This is also system voltage, and this 1.05 voltage goes to the processor as well as to the PCH, and now the PCH ready to work. Once he generate the 1.05 volt, this 1.05 volt pulse width modulator generate a power good signal, and this power good signal goes to the SIO, and this signal known as SA power good. SA power good, and this SA power good means all the power streams are okay. SIO will not turn on the power unless he get this signal. SIO turn on this signal, he turn on the VR on signal, sending this VR on signal on 11 step, but he wait till this signal it should get. Okay, it should get this SIO power good signal. Once he get the SIO power good signal 3 volt at this pin, SIO will generate a VR on signal at 11 numbers. He turn on the CPU core section, turn on the CPU VR on section, and CPU core generate a graphics core. It's sent to the CPU, and finally send the CPU core voltage. That is supposed to be approximately 0.8 or 0.9 volt. It goes to the CPU. It's with multiple ampere, something 20 to 30 ampere to the CPU core and 20 ampere to the graphics core. After getting this CPU core and graphics core voltage, CPU communicate with this VRM section, and this protocol is called the SVID. SVID means serial voltage identification signal. Serial voltage identification signal. He communicate whether the power which is sent by the CPU whether it is correct or not. If it is not correct, he inform to the VRM section, okay, I need this much of power. So he communicate with the VRM section, and once this voltage gets stabilized, CPU got proper power, this VRM section generate a signal that is called the V gate, or it's called the VRM power good. The VRM power good signal means this VRM section is working fine and CPU got the power. He generate this VRM power good signal at step number 13. Okay, and in step number 14, SIO generate a signal that is called the PCH power okay, saying PCH to that I done my job and all power planes are working fine. So he generate this PCH power okay signal, and here the both signal will connect each other, and the one final signal is generate that is called a system power okay at step number 15. The system power okay signal means the all power sections are okay. If you check this voltage here 3 volt, that means you no need to check all these voltages. If this voltage, if this signal is coming, that means the entire power planes are perfect, working all right. If this voltage is not coming, then system will be halt, it will go ahead. Okay, once PCH got the signal, then PCH started generate this 3 signal one by one. So he first send the DRAM power okay, saying CPU that RAM got the power and RAM is connected to you and you start communicate. So he send a RAM power okay, and then he will send a CPU power okay, and he will tell the CPU that whatever all the 3 power, CPU got the 3 power, that is called the VCCP, then VTT and CPU core. He says the CPU that you all powers are okay and you ready to work. And finally PCH generate a next signal that is called the PLT reset or the platform reset, and in platform reset he reset the entire motherboard and he reset the CPU also. He reset the CPU also, and once the CPU gets reset, CPU ready for work, and he access this DMI bus and like this and access the BIOS. So in this way we seen how this laptop's power sequence work. Suppose if your laptop is dead, if it is not working, it's not power on, so what you have to do, you have to check this 3 volt first on the DC power supply, or you connect to the DC power supply, check the current, and if you don't have a DC power supply, connect the adapter, open the laptop and check the voltage at SIO pin number VCC pin, or you can check on the EC bias pin number 8 also. 3 volts supposed to come. If 3 volt is coming on the SIO, that means your always voltage is working fine. The next step what you have to do, you have to check power button voltage, and your power button you should get a 3 volt. Once you press this 3 button, it goes to 0 and come back to 3. So there will be pulse will be generated at power button. After power button press, you should get the RSM RST signal. If this signal is not coming, then problem possibility either your SIO or your bias may be corrupt. So you have to reprogram the EC bias or change the SIO. And if this signal is coming, then you can straight away check this SLP3 SLP4 at pin SIO pins, and here you should get a 3 volt on the both the leg, SLP S3 and SLP S4. If it is these signals are not coming, that means the possible fault could be the PCH. Okay, yet the possible fault could be the PCH. If this signals come, then SIO turn on one by one signal, that is you turn on the SWIS signal first, SUSP signal second, and lastly turn on the VR on signal. But before turn on in the VR on signal, you check this signal whether he got the signal or not. And then finally he will generate the system power OK signal, then power is all the plane, and he generate this 3 signal. So in this way this Compal motherboard power sequence work for almost all this generations. Thank you very